Guys, hope you are doing fine. So today we will be discussing on distributed file system, and we will first start with Google file system, which is GFS. In this lecture we will actually understand how GFS works and what are the architecture of GFS overall. So GFS stores, whenever we are talking about GFS, we have to understand that GFS deals with large file, and how he handles that large file we will see that, and it also implements the eventual consistency part very well. So GFS stores the file into three different locations, and these three different locations are in three different regional locations. And while he is doing that thing, suppose we have a server which is suppose we are just having making a three copy for our to simplicity purpose. This is our server 1, this is our server 2, and this is our server 3. Now if any read operation is going on, any write operation is going on server 2, then server 1 and server 3 can go with any type of write operation, and that is allowed. What does it mean? It means that any information, he is not guaranteed that every information will be in sync. Rather, he is actually going with eventual consistency behavior. So that is the main fundamental stuff which we would like to cover up over here. And I would like to also mention like Hadoop, which is an open source project. It is also based on this GFS, Google File System only. Along with that, it also implements MapReduce algorithm, and this HDFS or Hadoop file system, which is itself a file system, is basically used by Facebook. So let's talk about the GFS or Google file system. So architecture. So first we have a master, and then we have some slaves, and these slaves are basically nothing but chunk servers. They are termed chunk servers by in the way they have described in Google file systems. Now these chunk servers will have a specific ID to designate. So this chunk server could be like chunk server 1, chunk server 2, chunk server 3, and chunk server 4. Suppose there are n number of chunk servers. Now these chunk servers will have its own data storage stuff, and they are basically commodity hardware. So they are basically commodity hardware, so there are tendency like they can fail. So that's why it has a tendency to go with a replication. So any item, any data item, it actually stores into three different locations. That means three different chunk servers, and these three different chunk servers, as we discussed earlier, belongs to three different regions majorly. Let's take an example. Suppose we have a big file, and this file is basically split it into some categories or some chunks. There are probably say for example there are 7 chunks over here, and every chunk has got its own chunk number, and if you just go and sum these chunks, then you will get the whole file, which is very big in nature. Now suppose, as they are mentioning, that every chunk size could be 64 MB. So eventually if you have 7 chunks altogether, then you are having 64 into 7 MB altogether as your file size. Now let's come back to the point. What is the responsibility of the master here? Master takes each chunk, whatever we are mentioning over here. Master takes each chunk and distributes among chunk servers. And how they distribute, as we have mentioned earlier, the way we mentioned earlier, in that way only master distributes that. That means masters, suppose we got a chunk for chunk 6. This is our chunk which master wants to distribute among chunk servers. Then master will keep this 6 into, say for example, 2, 3, 4, three different chunk servers, or 3, 7, 9, these three different RAM servers. Now the question is, why master does that thing? That because it's very simple, to make it more available, to avoid the fault tolerant stuff. So if anything goes down, anyone can pick and pick up the stuff and take the responsibility. Now if master needs to keep track where this chunk number 6 going exactly, what is the location of this chunk, so master maintains a data set, master maintains a database kind of thing where he is basically storing chunk number, right? This is his chunk number where, say for example, 6 is residing. He has got a chunk id with this, for this chunk number, say for example abc, and he has got something called locations. In this locations he is having the chunk servers id where the 6 lies exactly. For an example, I keep here 234, that means 6 lies in 234. So master keeps all these informations where he wants to query and get this result so fast, and that's the normal thing, that's the desired thing. So he keeps these things on RAM. As we have mentioned earlier, RAM has got very RAM is very efficient for fetching data so quickly, and it improves the response time as well. And we already covered one thing, like this chunk servers are nothing but the commodity servers. Let's talk about take a practical scenario where we can take and understand a read operation. Suppose this is our client application. Now this client application got its own server, which is termed normally as GFS software, that means Google front end software, right? And this is Google file system oriented software, right? And this software takes a huge responsibility. We will see like what type of responsibility it does. And suppose we have a server which is master. Now what happened, this client application sends a request to masters saying that I want to access directory 1 slash directory 2 and file number 1, and here I want to access chunk number 3. No, he shouldn't ever about chunk number 3. Rather, he gives something called byte offset. What is that? Byte offset is nothing but something where he wants to, from where he actually wants to read the data. Say for example, your byte offset is 1000. So from there, the client application or the GFS determines what is going to be our tentative chunk ID. So how he does it? It's very simple, 1000 by 64. So what is going to be the result is going to be the chunk ID what he is requesting to the master. Now what does that mean, and what this GFS is expecting? GFS is expecting the exact location from the master, like this chunk ID resides in which chunk servers, right? As we mentioned that there are 3 chunk servers. So for an example, we have chunk server 1, chunk server 2, chunk server 3 and chunk server 4. And these chunk servers has something like 1, 4, 5, 6. These chunk servers like 2, 3, 1, 5 and 3, 6, 5, 1. I'm taking some random numbers, 2, 6, 4, 3. Now you can see like 3 lies over here, 3 lies over here, 3 lies over here, but 3 doesn't lie over here. So master makes a query and understand like from his table, like yes, this chunk ID 3 lies on which chunk server. As we are mentioning, like he is keeping a table like this on RAM. So from there he just made the query. So master actually returns that to the GFS software that yes, there is 2, 3, 4, these 3 locations where your chunk ID 3 lies. Now GFS software understands which is going to be the closest location, who is going to be the closest to me. He is determining yes, 2 is going to be the closest me. So he is making a request from here and he reads the data. Look, one point needs to be understood here. Master doesn't access the data itself because it is going to be overheaded stuff. So that's why we give this responsibility to GFS. GFS software takes the responsibility for reading this thing. Master will first time return all the locations to the client. Next time onward, GF client will manage if any request he again the client needs to do for chunk number 3, which is on chunk number 3, then he won't call master because he knows this information 2 3 4. So based on this information he will be making his calls for reading those things, and definitely while he will be doing that call he will see who is going to be the closest one. Now before we go into the write operation, this is all about read operation. Before we go to the write operation, let's talk about fault tolerance. We are keeping 3 copies over here. If one software goes down, we can recover easily from other softwares, and we know that commodity machines are failure can fail anytime, right? It's a normal thing. Master periodically pings. Another thing which master does, periodically pings and understand what is the health of these commodity softwares or of these chunk servers, and based on that he actually does a health checkup, which is very important. Now you will ask one question, okay fine, everything I understood. Now what about if master gets failed, because master is becoming a single point failures over here. So yeah, for that reason what normally does, master actually talks about 2 other servers or systems. Suppose this is my M1 and this is my M2. What master does, the first approach could be like this: masters make some logging and make some checkpoints, like what is the current status of any sort of update or actions which has been taken on top of master, that is getting logged into M1 and M2, so, right? While actually these logs are being kept periodically so that we can understand the health about master, right? And every time any operation is being done on top of masters, this machine gets an update. And also we have to know that any sort of if data changes happening, that's get also entered or copied over here. This is one thing. Another thing is like synchronous replication. That means there is another type of copy of master which has been maintained. If any changes has been done into the master synchronously, that change is being made to his clone also. That means master also. Yes, in that case definitely if the master gets, the person who is changing the state of the master, he has to take a little bit more time, or he has to go with more expensive process because he is changing it synchronously. Yes, that is the thing where actually we need to discuss, we need to take a call based on our requirement. So we can have a discussion with an interviewer, like what is the exact demand. We can sense the demand, we can sense the requirement, and then we can take the call accordingly, and we don't think a lot. I mean, we won't face any problem. Let's talk about the write operation. In case of GFS, if we have this client application as we are mentioning earlier, and we have the GFS software over here, what is happening here is the master who is taking all major responsibilities. So as you know, we all know, like the request is going to be like directive 1 / directive 2 / a, and here actually we want to write something. So master will return what is our ID and what is the location. This ID is basically chunk ID, and the locations corresponding chunk server IDs it returns to the client. Now the client can do 2 things. Client directly, suppose we have 4 servers, this is server 1, these all are chunk servers. Let's talk about CS1, CS2, CS3 and CS4. Now say for example we determine that we will do make some changes on CS2. So whenever we are going to change, I mean whenever GFS is going to change on CS2, then this CS2 is termed as nothing but a very good concept here is called lease. So he is defined that he is on lease. So he is basically changing on CS2. But you can ask, like, we have three locations, suppose here 2, 3 and 4. These three chunk IDs over here, chunk servers over here, chunk servers 3, chunk server 4 also contains 3. 3 is basically the chunk number, right? So basically here we have can say like chunk number 3. So these 3 needs to be needs to be replicated, or these 3 we need to write over chunk server 3 and chunk server 4 as well. How that write happens? That write can happen in two ways. Either this server can write in a propagate manner in chunk server 3 and chunk server 4. This is one way. Another way is he can write in chunk server 3 or propagate that data into chunk server 3, and chunk server 3 can take the responsibility to propagate it in chunk server 4. In this way also the propagation can happen, definitely, for sure. Let's say client asks masters to write anything chunk number 3 and master sees like chunk number 3 is already on lease. Then master will give the whole information that chunk number 2, 3 and 4, among this chunk number 3 is on lease, so that the GFS software can have a knowledge on this and can take an effective decision, like whether he will be interested on the already leased machine or he will do something else. So basically this is the whole architecture of Google File System. You can have separate documents on this. You can study this. You can have a separate discussion thread as well. But this is a very interesting topic, and in the interview session also you can have a discussion on the interviewer and mentioning different aspects. Interviewer will be highly interested if you pick different type of aspects and describe it as far as the design standards. Hope this video is going to be help you a lot. So thank you so much. If you have any comments, effectively you can utilize comment sections. Thanks a lot.